Hi all, welcome back. For this video, I'll be covering question 7, 8, 9 and 12. Alright, let's get started. So the first question over here, a photon with light having a wavelength 434 nanometer falls in the visible light region to form a line in the emission spectrum of hydrogen. First question, name the emission spectrum series and determine the transition of the electron that is corresponding to the above wavelength and calculate the energy emitted in kilojoules. So from the question we have few information. First would be the visible light region. So for the visible light region we already know it would be the Balmer series. And next, calculating the wavelength for this transition. Since it's the Balmer series, we know n final equals to 2. So now we need to find what is n initial. Since we have the wavelength given to us, we can use the Rydberg formula, whereby wavelength given in 434 nanometers, you convert it into meter, substitute into this equation over here, okay, so 10 to the power of 7 over there, and then you would get n2, which is the n initial to be 5. So now please remember again, this was a similar question from previous video. They want to know the transition. Transition means what? Pergerakan elektron. So pergerakan elektron tu dari mana ke mana? That must be your final answer. Don't just leave your answer. Okay, don't just leave your answer at this stage. That's the common student mistake. You have to answer the question. So question wants to know which transition. So you have to mention from N5 to N2. Okay, so next question would be calculating the energy. Since we already have the wavelength, we can use the SPM formula delta E equals to Hc over lambda. Insert in the corresponding values. Now you might have a question. Madam, Planck's constant given in the list of constants is actually 6.6256 times 10 to the power of negative 34. So please use that. Okay, what I'm showing you is a simplified version of the schema jawapan lah. But in exam, you have to use 6.6256 times 10 to the power of negative 34 because that is given in your list of constants. Alright, so now we have energy in joule, but question specifically wants you to give your answer in kilojoule. Therefore, joule going into kilojoule, we would divide by 1000, right? And when you do that, you would get that answer, and energy emitted would be this. Okay, right. Let's go on to the next question, question number 8. A long question. Let's read together. First 5 lines in Balmer series. Draw first 5 lines in Balmer series on an energy level diagram. Next, use the Rydberg equation. They want you to specifically use the Rydberg equation and calculate the longest wavelength in nanometers. Next would be, would you expect the light to see the light corresponding to the spectral line? Explain your answer. So there's 3 questions in this one paragraph question. So let's go one by one. First 5 line in Balmer series. I think by now you are already pro in drawing this. Okay, as you can see. Now, although Balmer series ends with n equals to 2, I've mentioned this in class, you have to start your energy level from n equals to 1. Alright, next, the longest wavelength. Now, I told you in class, longest wavelength, try to relate it back to energy. Energy, as we know, is inversely proportional to wavelength. So if you want the longest wavelength, you must seek the transition that has the lowest energy, and that would be the first line, okay, or the first transition. So now first transition is from N3 to N2. Substitute in the formula correspondingly and you will get the lambda value in nanometers. Question wants you to give the answers in nanometers. How do we convert meter to nanometer? You multiply it by 10 to the power of 9. Okay, and the last question was asking on, can we see this transition? Yes, we can see, because this light and its wavelength is in Balmer series, and Balmer series happens in the visible light region. Okay, visible light region. Therefore, we can see this transition. All right, let's continue. Question number 9 now. Let's read the question again together. So, electron of a hydrogen atom is excited to the 7th energy level. So, can you see they didn't give numbers over here? So, we have to write it out ourselves so that we don't make any careless mistake. So, n equals to 7. All right. It falls down. Okay, it falls down to produce a line in Paschen series. So, Paschen series means n final equals to 3. So, state the electromagnetic region for this line. Calculate the wavelength of this transition. And next, you're going to calculate the energy emitted in kilojoule per mole. Meaning, can you see the question is only referring to one electron? An electron. So now, when the question is asking you to calculate for kilojoule per mole, that means they want to know what is the energy for 6.02 times 10 to the power of 23. Okay, electrons making this transition. All right, and finally, calculate the ionization energy for hydrogen in kilojoule per mole. So let's go one by one. So where's the region? The region would be infrared because it's Paschen series. Now we know n initial is 7 and final is 3. Substituting in the correct formula of wavelength using the Rydberg constant formula for wavelength, you can find the final answer of wavelength to be 1.005 times 10 to the power negative 6. Next, we are going to find the energy, okay, for one electron. As you can see over here, since we have the wavelength, you can use the SPM formula to calculate energy of an electron making the transition. Now we need to find energy for 1 mole of electron, and that would be this answer over here. So please press the calculator and confirm that this answer is same as your answer. Please don't just copy the answers. I'll be checking this on Monday, Tuesday or Wednesday, depending on the class. So again here, quick reminder, this would be 6.6256 times 10 to the power of negative 34. So because you're inserting in a 4 decimal place value, you might have slight variation. And as you can see here, lambda is also given to almost 4 decimal place. 3 decimal place is fine, so that your energy value will be a more accurate number. If you were to round it off early, you might get difference here. So make sure if you are using this value again to improve the significant numbers and get the final answer. All right, now calculating the ionization energy for hydrogen. I don't have a direct working here because this working is already shown in your lecture notes. It's the same working. So let's just quickly recap. How would you calculate the ionization energy? So delta E formula equals to Rydberg constant and n initial squared minus n final squared. Now since we want to ionize, that means we have to pull the electron far away. Until where? Until it reaches a very large number that we call as infinity. So this initial stage will be the ground state of hydrogen, that is 1. And what would be the final state of the electron in a hydrogen atom if it wants to undergo ionization? That would be infinity. So when you do this, you would get an answer which is 2.18 times 10 to the power of negative 18 joule. Okay, so once you have that, this question is again asking you in kilojoule per mole. Therefore, all you do is multiply it with Avogadro number. Your final answer should be about 1312 kilojoule per mole. So please look back at your lecture notes for this calculation and write it in. Okay, right. So let's continue with the final question for this video, which should be question number 12. Very straightforward and simple question, not asking you to draw anything, just to understand that these are the first 5 lines in bracket series. State the region, again a very simple answer, infrared, and which would be the shortest wavelength. Shortest wavelength would be that with the highest energy, and I would say it's A. Okay, A has got the highest energy. Okay, let me write that. A has got the highest energy. So highest energy means the shortest wavelength. And that would be line A. A quick recap, first 5 lines in bracket series, meaning and final equals to 4. So all these transitions are going to end up with 4. The start of the line spectrum is from here. So the first transition is 5 to 4. Second transition is 6 to 4. Third transition 7 to 4. This is 8 to 4 and 9 to 4. Boleh? Alright. So that's all for this video. I'll see you in the last video explaining question number 10 and 11. Thank you.